Okay, we'll get started in 1 minute. Get set up, get logged into Blackboard. I posted the PowerPoints. Unfortunately, the book publisher, for some reason, I don't know why, they made PowerPoints for this edition of the book that we're using in class, but they're like incomplete. There's like slides missing and something's wrong. So it's essentially the same information as the previous edition. So I just posted those, but you can access those under PowerPoints. And I just enabled that not that long ago, so you might have to refresh the page to see it. We'll wait 1 more minute in case anybody's running late, but I don't want to wait too long. So I guess if we're waiting for any other students and everyone's good with masks and everything, okay, perfect. A couple quick announcements. I got a request for a note taker. I really don't know almost any of the details. It's just you'll be paid $100. I don't know for sure, but I'm assuming that 100 is for the entire semester, not like 100 per week or month or anything. From what I could tell, I've never gotten. I just don't know very many details. So I would just say if you can take notes every class, and $100 is a good amount for you, assuming it's over the entire semester. I don't know the details, but that's what I'm assuming. Go ahead and email me, and then I'll forward your contact information. Okay. And then assignments. So make sure to keep track of your assignments. Don't forget that, and I'm a little bit behind on grading. I'll try to get this one graded today, this assignment number 1. That way you can have your grade for it. So this was due last week, but you can always click the assignment and get the due date. Okay, everyone's aware of that. I realize not every instructor at IRSC always puts a due date, especially for the online classes. It can get, I know it's a little inconsistent where they do a separate like calendar for the online classes, but for my live classes, if you ever take another class with me, to me this is it's kind of nice that it's tracked directly in Blackboard. So, and don't forget that your grade in this course is the midterm, final, and these assignments. So there's not a whole lot to keep track of. So as we get new assignments, and I'll always announce them in class, you just click the assignment. It gives you the due date, and then maybe keep like a personal calendar to keep track of all your classes. If you have a smartphone, which I imagine most people do, there's usually calendar apps like built into the phone, or some people just like a regular old paper calendar. That works too. And then keep track of these points. So some of these initial assignments aren't worth that much. It's just to kind of get you used to turning in assignments and that whole part. But starting from assignment number 3, this is much more typical of what the assignments will look like. They'll be anywhere from like 10 to 15 questions. And they'll be worth, in this case, so this is 9 points. This would be 9% of your total grade. So at the end of the course, all these points add up to 100. So that also means, like I said, because your grade is assignments, midterm, and final, that these assignments are worth a lot, because I don't do attendance grades, I don't do discussion grades, those sorts of things. I don't do like a daily quizzes or anything like that. Your grade is your assignments and your midterm and final, so that if you miss any of these assignments, it puts a in general it'll knock off almost an entire letter grade going forward. Some of these initial assignments, like just installing software, this one was, since it's not that complex of an assignment, it's only worth 3 points, but starting from 3 forward, this is going to be pretty typical, anywhere from like 7 to 11 points, somewhere in that range. Okay, so I'll make sure to get assignment number 1 graded today. Assignment number 2 is due today. Any questions on that? One thing I do want to go through very, very briefly before we get into today's PowerPoint slides and the material for assignment number 3 is I want everyone to go to so Google or whatever search engine you like. Notepad++. I might have even made this recommendation that Notepad++. Did anybody use Notepad++ for your assignment too? Okay. So and all this is it's kind of a programming joke, I guess would be the I don't know if it's so much of a joke, more like a inside information. So there's a piece of software on Windows called Notepad. And it's extremely basic. It's just like a plain text editor. You don't get anything extra. It's a super simple piece of software. It's been around probably since the very first versions of Windows. And it does its job, and it has one job, and it does it well. But there are times where you need some extra features. And in programming, plus just means increment by 1. It's a very common thing. You'll learn about when you take a programming class, and there's like the language C++ meant increment the language C by 1. And that's what they kind of did here, is they did Notepad++, so it's like supposed to be a little bit better. It's not from Microsoft, but it's very popular, especially if you do any sort of, I wouldn't do any serious programming in this, but if you need to make some quick edits to certain file types, it's pretty decent. So it's very popular. Open source piece of software. So if I go to download the recent version. What did we talk about last class? Remember we talked about 32-bit and 64-bit versions? So in your own words, you don't have to be overly technical. Does anybody remember the difference between 32-bit and 64-bit and why we have 2 versions? So up until probably about, very generally speaking, maybe about 10 years ago, most of our processors were 32-bit. And maybe some of you who play a lot of video games remember like the original Nintendo's entertainment system was 8-bit, and then you had 16-bit systems, and then 32-bit. So that refers to certain properties of the processor. And the idea is the wider the bus, the more data you can get through and more information. And in the case of video games, I'm guessing that you could get more advanced graphics and more advanced gameplay is kind of the pitch with doing that. Some of it's probably marketing, I'm sure. But and so for a long time, 32-bit was sufficient, because if you were to do the math on how many things you can count with 32 bits of information, remember computers use 1s and 0s, so you got 32 bits, you do the math, 2 to the 32, you get a number around 4 billion, which for most purposes is good enough. And so for most of the 90s and into the 2000s, 32-bit systems, 32-bit computers were sufficient. But what that also means is that if I can only count to 4 billion, remember we talked billion is associated with giga. So 4 billion bytes is 4 gigabytes. That means that it can only use 4 gigabytes of memory. Well, I mean, on this computer alone, I think this one's 8 gigabytes. So around the time that people started to run up against that limit, they said, okay, well, it's clear we need to increment this from 32 bits. 32 bits is no longer good enough. We'll go to 64 bits. For various reasons, software, sometimes they will still build it for 32 bits. I'm actually not completely sure why they have this as the first choice, because there aren't that many 32-bit systems around anymore. So for the most part, your default choice is going to be 64 bits, unless you have specific information, like there's a reason you want 32 bits. They've had 64-bit processors for a while now. I'm guessing most people are using 64 CPUs. And so this is kind of a little bit more advanced of I don't know if I should say advanced. They give you more choices. If you download software from most large software companies, what they're going to usually do is try to do the opposite. They're going to give you one installer, and they're going to make it as simple as possible. But this is open source software. It's very customizable. So they give you a lot of choices in installing. So your typical installer will either be what's called an MSI or an EXE. And this is kind of the whole reason I'm going on about this, is that sometimes you'll actually see software as a zip file. So what's the difference between having the installer and a zip file? When you run the installer, it'll do extra things on your system. For example, if I wanted to right-click and open with that Notepad++, that installer registered some things with Windows and said, "Hey, I know how to edit HTML files," and they put something here to where you can right-click it. So you get typically some extra things when you run the full installer, but sometimes all you want is the separate zip package, because once you've had a computer for a while and you've installed software over the period of like 5-6 years, people are using their computers for a really long time now. Your system gets kind of cluttered. So sometimes I prefer just the zip file. So I might download the zip file, save, go to downloads. So we'll see NPP, which stands for Notepad++. If I double click it, it looks like just a regular folder. It's not. This is something called a zip file. It's very important you know kind of these details. A zip file, so zip was a format created many, many years ago when we didn't have fast internet connections. If I wanted to send you a file, we would compress it using a format called zip. It's becoming less common because internet connections are so fast these days. You only really need to zip things if they're really huge. If they're just like a few megabytes, you tend not to need to zip it as much. But one of the other things that it did is when you zip it, it takes all the files and all the folders and it puts it into one file, this one zip file. So it makes it very easy to send. I don't know if anybody's ever tried to email a lot of files before where you had to individually select them and it gets kind of complicated. The nice thing about a zip file is it takes it and puts it all together. Now, one of the things that Windows and Mac does this as well is if you double click this, they give you a preview version, but it's not unzipped. It's still the zip file. And I see this in a lot of different classes. That's why I'm bringing it up. I see this from freshmen all the way up to seniors, is that people will double click the zip file, not realizing it's still zipped, and then think, oh, okay, I'm going to run this. And it gives you a little warning that says, do you want to run it? I click run, and then I start getting weird error messages and things don't seem to work. This is just a very, very crude, simplistic preview of the file. I wouldn't use this for anything other than seeing what files are in there. So what do we want to do? There's this button up here to extract. And then notice now in my downloads I have the zip version and the non-zip version. They might look identical when I go into the preview. I click the zip and the non-zipped version. But this one's actually a true Windows folder that I can go in here and run this without any issue. It might complain that I already have installed. Okay, I guess it didn't. And again, why would you want to use the zip file instead? It's nice because when you install a piece of software, it like goes deep into your system. It puts registry entries. It might put app data all over your system. When you've got a self-contained version of the software, it's kind of nice because if I wanted to delete the software, literally all I have to do is delete and it's gone. I don't have to run some sort of an uninstaller. And uninstallers aren't perfect. I can't tell you how many times I've uninstalled a piece of software and then like a couple of years later I still found like little bits of it throughout my system as I'm looking for other things. I'm like, I thought I installed that software a long time ago. So okay, don't want to spend too much time on that. Make sure to get assignment number 2 done. Let's hop right into assignment number 3. So what I would suggest for most people is that during class we're going to go over a lot of the answers to this. Now obviously always pay attention and participate in class, but what it might be a good idea to do is open up Microsoft Word and copy and paste in all of the questions. And we'll read through all of them in a second. And as certain things, say, oh, okay, we're talking about IP addresses. I swear there was some sort of question about IP addresses, and you scan through it real quick and say, oh, okay. And then answer that question. Okay. It also gives you some incentive to actually show up to class. Now, most of this stuff is in either the book or you can look it up on the internet. But what I've noticed in the past is people who don't attend class frequently will often give me very strange answers for these. It's like they look up the answers on the internet, and then has nothing to do with what we were talking about in class, and it'll be just this. It'll be very obvious that it wasn't based off of the class discussion. It's very easy to get perfect scores on these if you show up to class and pay attention. Okay, this class is meant to be easy. It's meant to be like fun. It's supposed to be a gentle introduction to all these topics. My goal isn't actually to make anybody's life difficult with this class. It's actually to get you interested in technology that way, and give you kind of a preview of what the other classes are. So I try not to be difficult with a lot of this, and if you just kind of keep this open, and as we go in class answer these, you'll be okay. Okay, so question number 1, what is the internet? One quick thing, the internet and the web aren't really the same thing. The web is built on top of the internet. We'll talk about some of that, but just keep that in mind. The name of the organization that created the early internet. So we're going to go through and open a command prompt, and what I want you to do is tell me your current IP address. So some of you may do this at IRC, some of you may do this at home, so you'll get different addresses. What is the TLD, which stands for top level domain in www.google.com? What does the acronym DNS stand for, and what is the purpose of DNS? Why do IP addresses exist? Give me an example of a URL. And then every once in a while, what I'll do is give you a research question, stuff that's not really in the PowerPoint slides or necessarily in the book, just to get you used to going out there and searching for answers on your own. And this one is, name 2 search engines not geared toward US customers. So a lot of times we're very like US centric, and we think that like Google is the only search engine out there, but in many countries it's not even the most popular search engine. There's search engines that are geared toward just those countries. And I give you 2 examples, but you can choose whatever country. Name the 4 most commonly used web browsers. Name the first web browser. That's a research question. Who is considered the father of the internet? That's a very common phrase. That's why I specifically use that. It's something that's very easy to search for. That's a research question. And then what is the difference between HTTP and HTTPS? Okay, so let's get right into these slides here. Sometimes I actually full screen these. Sometimes I don't even bother. But we'll start off full screen. Let's see how it goes. Okay, so going back to the very first computers, right around World War II, the first computers were very good at being very fancy calculators. And there used to be, again, an occupation where all you do all day is compute a bunch of numbers. And humans kind of have a limit. Even the fastest person can only compute numbers, at a tiny fraction of the speed as a machine. And so there's this guy, Alan Turing, that did a bunch of mathematical proofs and showed, okay, well, if you created this machine, it's not like he sat in his garage actually creating the first computer. He did it all through mathematical proofs. If you created this machine, anything that you can solve computationally, essentially with math, you can solve with this machine. And then a bunch of people right after World War II saw how important this could be. Mostly a guy named John von Neumann. And he helped create the first computer, the ENIAC. What's interesting is that to this day, that first computer, what's called the von Neumann architecture, we still use that today. Modern computers still pretty much across the board use von Neumann architectures. There are some that don't, but for the most part they do. And they solved a very interesting problem in that they could do a lot of computations, typically what was called batch. So I would feed it a problem, I would come back a day later, it would give me the answer. It would say, okay, if you want to send send a rocket to the moon or send a satellite out into space, and you use these parameters at this angle and this thrust and all these other things with this air resistance and all these different things, this will happen. Same thing maybe with weather. Very good for a lot of number crunching. As time went on and computers became a little bit more of a commodity, it went from having like 5 or 10 computers in the entire country. All of a sudden, you've got dozens, hundreds, thousands of computers, Now, we're still not into the age of everyone having a computer at home, but in the 60s and 70s, a lot of people were getting computers, and we went from just, like I said, maybe 5 computers in the whole country to tens of thousands maybe. Probably more. I wouldn't take my numbers as super accurate, but in that general range, order of magnitude. And if I'm working on a very large project, say for example MIT on the East Coast, Stanford on the West Coast, and I want to share data, for example, if I'm doing, maybe MIT is working on some part of a system and Stanford is working on another part, and they want to put all their data together to run a more complex simulation. Well, at that point, I would have to put all my data on a hard drive and then put it on a plane and send it across the country. Or even worse, maybe something like paper. And they thought, well, we've got all these telephone lines and these different ways that we communicate with voice. Can't we do that for computers? And through a collaboration through the military, government, and universities, they created the first computer network, which is called ARPANET. Okay. By the way, this second bullet point drives me crazy. By default, the internet and networks are not secure, and actually, that's like a huge problem. Is because from the outset they thought, oh, it's just going to be like universities and military installations sharing data with point-to-point contacts. We don't really have to go to any extra effort to secure this. So from the beginning, the early internet was actually never designed to be secure. It was actually meant to be very open, in fact. And that has caused us problems ever since. So I'm not sure how the book would make that big of a blunder, but and we'll get to that in a little bit. Now, let's take a step back. Okay, so we've got this idea of being able to share data across the country. Let's think about our simple classroom, and I think I've gone over this sort of thought experiment before. If I've got a classroom full of computers and I've got a bunch of students working on a project and they want to be able to share data. So let's say, for example, we're working, the class project is to make a video game. Somebody's making graphics for the video game, some person's making sounds and audio for the game, some person's maybe working on like the actual coding of the game. You've got a bunch of people doing a bunch of different tasks. But ultimately, they're working on the one game. So how do they share all that data together so they can put the game together? Well, we could grab a bunch of like flash drives and put them on each person's computer, but that's not really realistic. So what do? We take a network cable and we connect the computers together. Now, don't worry about the specifics of how we do that because we'll get to that later. But now we've gone from an isolated computer to 2 computers that can now communicate with each other and they can send data back and forth. So I can do that for 2 computers. Then a third person shows up and I want to be able to share data with them and share data with them until I've got all the computers in the classroom all talking to each other. And we put them all together in a box, usually called a switch or sometimes a router. And then so all the computers in this classroom can communicate. And that's what's called a computer network, is setting up a system where a bunch of computers that normally would just be alone, isolated by themselves, taking that and making it so that they can talk to each other. And I say talk in quotes because that talk part is where we get into the different protocols and stuff, but we can just very generically say talk. Well, that's great. Well, what if I want to talk to the classroom next door? So all their computers are networked together. These computers are networked. Then we take the 2 switches and then we plug those in together. And then we do the same thing for each floor in the building and each building on the campus and then each campus at IRSC. And then, well, what if I want to start talking to UCF or Palm Beach State University or other colleges? Then you take the colleges themselves and then you link them together. And you keep on doing that and doing that and doing that and doing that until you form the internet. So what is the internet? It's these individual small networks all connecting together. So you can say, just very briefly summarize, what is the internet? It's a network of networks. that make sense? So you take these tiny little networks and you keep on building them up until this computer that's in front of me can find a network path all the way out to Tokyo or somewhere. Given enough hops and paths and going from room to campus to different places. So that's essentially what the internet is. Now, the early internet was actually very, very simple. So there's an organization called DARPA, Defense Advanced Research Projects. So there's an organization called DARPA, Defense Advanced Research Projects Agency, and they were the ones that funded the early internet, which was called ARPANET. So DARPA funded ARPANET, and the actual network itself was ARPANET, and that eventually morphed into what we now know as the internet. Now, to give how small the original ARPANET was, in 1977, the internet was small enough to be able to put on a diagram. And this is essentially a diagram of the entire internet in the 70s. So, and if we look hard enough, we can probably see some things that we recognize. Okay, so we can see Harvard right here, a bunch of computers. You'll see a lot of these computers, the PDP. The PDP was a computer that was very popular in the I guess late 60s, 70s. It's not around anymore, but it was from a company called DEC, Digital Equipment Corporation, which, why am I telling you all this? Well, that's the system that they created the first Unix system. And although PDPs aren't still around, Unix is everywhere. You might think, well, I've never used Unix. You actually probably have. Apple and their iOS and desktop operating systems are Unix-based. Your Android phones are Linux-based, which is based off of Unix. And anytime you're using a server, there's a very good chance that Linux is involved in that somehow. So even if you're using a Windows desktop, there's a good chance that you're interacting with that. So just a little bit of history, but that's why you see this everywhere, this PDP-11. This was a very popular computer then. So we see Harvard on the East Coast, NYU. And then maybe over here on the West Coast, so we see Stanford, and so on. So you can see how small ARPANET was in 1977. Now, there's a bunch of different ways to communicate. Remember I told you, I just kind of waved my hands and said these computers can talk to each other. There's a bunch of these what are known as architectures. We'll go over this in some more detail later, but the main are client-server and peer-to-peer. So peer-to-peer is if all these computers in the classroom wanted to share information. They could all talk to each other. They'd all have to be made aware of each other. And peer-to-peer, in theory, seems maybe simplest, but in practice, it's extremely, extremely complicated. Most of the places you actually tend to see successful peer-to-peer is mostly just file sharing, because files aren't that complicated, especially if they don't change. If it's like like music or something like that. That's why it was so popular with music sharing, because once a song's released, that's pretty much the song, and so you can share that via peer-to-peer. It's very resilient because every computer is kind of talking to each other, but it's kind of complex. It's hard to manage. In most enterprise networks and in most situations, we actually use what's called client-server, and the idea is that there's one. And this has sort of changed over time, but conceptually think of one computer and let's say, for example, the IRSC website. We'll pretend that's one computer, and if people want to visit the IRSC website, they connect to that computer through the network. So it goes through its network path, it finds that IRSC website, and then it sends back the website. Now that's great because it's very simple. I just go to that one server and I return the information. But what happens if that server is damaged? Can I still get to the website? It's like say for example somebody bumps into it and rips out the network cable or the power cable. Can I still get to the website? No, because that server's down. Now over the years we've come up with very clever ways of very fancy hardware that's like redundant, and a lot of times a server is actually not one physical computer. It's actually a little bit more complex, but you get the basic idea, is that you're the client and then you go to some server to grab information. We'll talk about these in more detail. Unfortunately with the book it can get a little bit scattered because this is probably not the place to talk about it. So let's talk about IP addresses. So I previously mentioned that all these computers in the room want to be able to talk to each other. And I, again, waved my hands and was very high level and said just, hey, throw a cable at it and magically they can talk to each other. In the real world, if I want to call somebody, what do I need? Can I just call them? What piece of information do I need to say? For example, I wanted to call and order a pizza right now. What piece of information would I need from that company? You need their telephone number. And in the world of phones, that's how we get a hold of people, is that telephone is connected to a phone number. What about your mailbox? If I wanted to send somebody a letter, what do I need? Their address. We have essentially the same thing on the internet, is that if I want to be able to contact another computer, I need their IP address. Now, what do these IP addresses actually look like? So everyone do this. Open up a command prompt. So to do that, click Start and then do CMD. While you're doing that, let me just make sure that we are still streaming. Perfect. See if I can make this a little bit larger. Let's go over to the perfect, okay. So a lot of times I mentioned that the book likes to talk about things very generally, but I want to give you some concrete things. So here we have a command prompt. Unfortunately, we don't really have too much time to talk about I think we'll get to command prompts at some point later in the course. And then we type in what's called a command, and the command to see information regarding IP, which stands for Internet Protocol, is ipconfig. Now, this output can be very confusing because these days you'll see things like a Bluetooth network adapter, and sometimes you'll see, I don't have VMware installed on here, sometimes you'll see VMware, like virtual adapters and stuff like that. So 20 years ago this would have been much simpler because you typically just had your Ethernet cable and one network adapter. It's gotten a little bit more complex because a lot of times we have multiple adapters, and sometimes we'll have virtual adapters and VPN adapters. But in this case on my computer, the one that actually has information that I care about is this wireless LAN, so Wi-Fi. And you can see here, we're not going to talk about IP6 addresses just yet, but this is the one you're probably most familiar with, is this number. So it'll be a number from 0 to 255 dot another number dot another number dot another number. Okay, so this is your IP address. Let's very briefly talk about, so I'm using this acronym IP without really talking about very much detail. Let's even take it one more step back here. So all these computers are talking to each other, and they know how to get a hold of each other by their address. That's how they know how to do that. And I'm telling you that they're all talking to each other over something called IP, Internet Protocol. Let's dissect that a little bit. So protocol, this term protocol, what is a protocol? In just our everyday lives, if I have to follow a protocol, it's like a set of steps to ensure something correctly happens. With technology and communications, you can usually think of a protocol as like a way to speak. For example, I'm speaking to everybody in here using English. That's the protocol, is that I'm speaking English, and you walked into this classroom assuming that I was going to speak English, and you're able to understand me. If I walked into this classroom speaking Japanese and you expected me to be speaking English, we would have kind of a difficult time communicating. Now, computers are the same way, and actually computers are actually even much more formal than that. We have to come up with very detailed rules on exactly who can speak, when, for how long, what happens if I can't hear you correctly, do I say that thing again, how do I let you know that I can't hear you clearly, and so on. So all of that's what is a communication protocol. And specifically, when we communicate over the internet, well, the internet's very complicated because it can be unreliable, and it can get slow sometimes and fast sometimes, and so we can't really assume that it's going to be a certain speed. We can't really assume almost anything about it. And so this guy created and this is actually part of your research question, a set of protocols called TCP/IP. And these are the protocols that we've used pretty much since the 70s for communicating over the internet. And they handle all these things that I've talked about. If we've got one side operating at a speed, another side, if I need to retransmit data and information and so on, it handles all of that. So that's called, there's actually two parts of it. There's TCP and IP. We usually talk about them kind of as one unit, TCP/IP. And within that, to be able to communicate to each other, we have to have addresses, these things called IP addresses. And this is an example of one of those addresses. Now, like I said, they bounce around with stuff I don't think is necessarily important. Let's stick to IP addresses for a minute. When I go to IRC's website, so here's the IP address of the IRC website. Do I actually type do I actually just type in the IP address? Like, do I open up my browser like Chrome or Firefox or whatever? Do you actually go and type this IP address? No. What do we type instead if I wanted to go directly to the IRC website? www.irc.edu, right? So there's this system called DNS. It stands for Domain Name System. And what it does is, so let me take a step back. So as people, as humans, we're very good with readable names and things that mean something. For example, if I go to irc.edu, locally everybody in the whole area knows exactly what IRC is. If I were to go to one of the local county or city websites, same thing. Or if you're going to a social media site like Twitter or something like that, you type in twitter.com. These are all things that we as people tend to remember names very well. We're not that great at memorizing numbers that have really no meaning to us. So why is it that we have these numbers at all? Computers and machines are really, really good with numbers. That's why we have phone numbers, is they can be organized and segmented in different ways. Like with a phone number, we can have area codes, and then we can take a range of numbers and mean that range of numbers means that you're on a certain carrier, like say T-Mobile. And in general, computers are just really, really good with numbers. They're not really good with these names, because you know how, like, to you and I, this number is essentially meaningless? To a computer, www.irc.edu is essentially meaningless. It's like, it doesn't really have the concept of like grouping together things in the same range and knowing that they're maybe from the same network carrier or something like that. So we've got these two competing factors, is that we've got people are really good with names but bad with numbers, and computers are really good with numbers but bad with names. So to bridge that gap, we have a system called DNS, Domain Name System. And what that DNS does is that it lets us convert between these human readable names called domain names into these numbers, so that we generally don't really have to deal with these numbers very often. If you're a network administrator, you'll typically have to make the mapping between these two. But in most people's daily lives, they actually don't have to deal with IP addresses very often. Most of the time, actually, that you have to deal with an IP address is when somebody hasn't made a DNS entry somewhere, which maybe if you're like creating your own game server or something like that, you might have to give somebody your IP address because you don't really have the resources necessarily to create that. But so that's the system we use. It's called DNS, Domain Name System. Yeah, let me make sure I'm... Every once in a while, I'll hop back over to these questions just to make sure I'm making good progress. And by the way, I will do some of these out of order as well, depending on, just whatever the flow of the class is. Okay, so I'll give you a quick 2-minute summary. So in the early days of computers were these isolated things that were very good at number crunching. As more and more people got computers, and mostly military and university, they wanted to be able to share data. So we came up with the idea of a computer network. And all these computer networks wanted to be able to talk to each other. And as we expanded that and expanded that and expanded that, we ended up with the initial version called ARPANET, which eventually became the internet. Okay, so we have that. And then for all these computers to speak to each other, we need a set of protocols. It's a set of exact steps and guidelines that say, okay, if I want to speak to this computer, here's all the rules to be able to speak to this computer. And the set of protocols that we use are TCP/IP on the internet generally. There are other protocols, but the bulk of the time you're going to be using TCP/IP. Okay, well, I've got this set of steps and protocols to speak to other computers. How do I actually say I want to contact this specific computer? To do that, we use what's called an IP address, an Internet Protocol address, and it's a set of numbers. That can be kind of inconvenient because as people, we don't deal with numbers very well. We deal with names. And so we created this system to convert back and forth called DNS, Domain Name System, where I can give DNS a name like www.irc.edu, and it'll convert that into an IP address. They actually have something called reverse DNS, which isn't as useful. Sometimes it can be. Most of the time you're going to be using regular DNS, but you can actually convert back the other way. Sometimes this gets a little bit tricky, but anyway. So that's in the 70s, rough time frame. Now in the early 90s, okay, so let's talk about the 80s. So we've got the internet created in the 70s, and in the 80s more and more people had computers. To be able to do anything on top of the internet, like these things called bulletin boards were very popular, people would create things on top of the internet. So the internet is very general. It just says, okay, if you send me a piece of data, I'll get it to the other side. But it doesn't really say very much about the specific type of application of that. This is what later you'll learn about called OSI layers. So for example, do you want a chat program? Do you want a file sharing program? Do you want a we'll keep it simple. So we'll say file sharing and chat. So, or I have actually another example, email as well. And so on top of the internet, people created these other protocols. So for email, there's one called SMTP, Simple Mail Transfer Protocol. For chat, there's one called Internet Relay Chat. And these are all created around maybe 70s, 80s time frame. And in the late 80s, early 90s, a guy named Tim Berners-Lee came up with the idea, which eventually became the web. Now, the web is not the World Wide Web is not the same thing as the internet. The web is built on top of the internet. The internet is a very low-level thing. This is what we typically do, is we layer things and we build on top. So they created all the basics in the 70s, probably 60s and 70s for the internet through ARPANET. And then it made it so that people could build things on top. And then this guy named Tim Berners-Lee said, oh, okay, well, the internet's very popular. he was a scientist. He had to deal with research papers and documents a lot. And at that time, we would have a bunch of isolated documents. So I might write a research paper, and I'd say, to see more information about this other related project, go search this database somewhere else, and then you'd go find that database. It'd take a while. So what he wanted to do was take these documents and link them all together through hyperlinks. We don't even think twice about it today. If I go on the IRC website, I can click 10 links in a matter of a couple seconds. If you're very fast at navigating that. But back then, to go through 10 documents took a long time. You'd have to find who owns the document, get access to it, and so on. And so what he created is this system of documents and linking them together, which eventually became the World Wide Web. Now, the original web was very, very primitive. It was really meant for research papers. It was never really meant to look very nice. It was just very simple text. Actually, in one of my other classes, just to give you a sense, I'll usually go through, even though it's kind of unrelated, this is for our web development class, but you may actually find it kind of interesting. This is a timeline of the web. So in the late 80s, and some of this stuff's kind of unrelated. It's just random stuff. But to give you a sense, this is what early websites looked like. So this is the original Amazon website. If you compare that back then to today, this is the original Pizza Hut website. Okay, sort of gives you a sense of what they were working with in the early 90s. But it had the basics there. It had it so that you could link things together. To access that, you needed something called a web browser. Because what does a web page return? It returns this thing called HTML. So if I go to a page, what does that server actually send me? It sends me this. This isn't that practical for me to do anything with. This is called HTML. So what does the web browser do? The web browser interprets that HTML, and it makes it so that I can actually have some sort of readable text. Okay. Now, there was a very early browser called Mosaic that eventually became Netscape. And Netscape was a pretty successful web browser. You had to pay for it back then. These days, I don't think anybody really is paying for web browsers. Maybe Opera people will still pay for, but for the most part, you're not paying for web browsers. Back then, it was like $30 or something like that. But it made it so that you could actually connect to the web and view these web pages rather than getting just a bunch of HTML. At the time, Microsoft and Windows were like taking over. And Microsoft didn't like the idea of somebody else's web browser making money. So what they did is they created a web browser called Internet Explorer. And so at the time, in the 90s and the early 2000s, there were really only two browsers out there. There was Internet Explorer and Netscape. And those were the two most popular. Eventually, the company Netscape kind of went under. They open sourced all the source code from Netscape, which eventually became the Mozilla project. And then they went through another iteration where Mozilla was this very bloated piece of software. They kind of cut the extra pieces away that they didn't need, and eventually that became Firefox. So the Firefox web browser has its roots actually all the way back to the original Mosaic web browser. Safari is less important of a player in all this. There used to be a Windows version of Safari. I'm pretty sure that's gone. So for the most part, only Mac users are using Safari. Microsoft Edge. So what they did with Internet Explorer. So Microsoft during the 90s and early 2000s, they actually had a name for it. It was called Embrace, Extend, Extinguish. So they would take an open protocol like the web. They would embrace it. they would make their own proprietary extensions, and then eventually it'd make all the other competitors go away. They actually had an antitrust lawsuit that was the result of all this. But that's what Internet Explorer did. Internet Explorer had all these proprietary extensions, and that's one of the reasons that actually Netscape went under, is because they couldn't compete, because Microsoft was always coming up with extensions. And actually it was very common in the 90s and early 2000s that you'd see on the web page, it would say like best viewed with Netscape or best viewed with Internet Explorer. You don't really see that anymore. Eventually what happened is Internet Explorer was such a terrible browser that they did a complete browser rewrite that became Microsoft Edge, which never really gained that much popularity. And what they eventually did is they gutted Edge, and just in the past year, Microsoft Edge is actually just kind of almost like a skin on top of Google Chrome. It's like so if you're using Microsoft Edge, the current version in September 2020, it's mostly Google Chrome. So I don't remember the stats off of my head, but I think it's generally a tie between, or maybe Google Chrome is a little bit ahead as far as browser popularity. So you know the brief history of Firefox, you know the general history of Microsoft Edge, and then some, let me get into Google Chrome. Google Chrome is kind of interesting because Google is a web search company, and they make their money off of ads off of those searches. They really had no interest in ever making their own operating system like Windows did. They knew the whole time as a company that they were always going to be a web-based company. Yes? Yes, like around 2010, they did. So this is kind of going back to like early 2000. Yeah. So at that time, they knew they were going to be. But you're correct. Yeah, they did. Today they actually do develop operating systems. They have probably like 3 or 4 that they develop. But at the time, back in the early 2000s, their whole existence as a company, they knew they were going to be embracing the web. Well, it made it very difficult to embrace the web when the most popular browser at the time, Internet Explorer, was always changing the web and was making life very difficult. So they wanted to introduce competition for a more open web, because the more open the web was, it made it so that they could release their web-based products. So think about the early versions of like Gmail and Google Maps. At the time, these were revolutionary, because at the time, people weren't doing web-based email. The few web-based email systems out there were terrible. For the most part, people were using Outlook. And it just didn't even occur to anybody that you could have a web-based email client that wasn't terrible. And so that's eventually where Google Chrome came from. And now Google, at the time, in the early 2000s, they were like this very young, scrappy company. Now they're this giant behemoth. And there's unfortunately been some consolidation. Like I said before, Google and Chrome, so Chrome and Microsoft Edge, Microsoft just kind of gave up. I think they just never were really able to recapture the popularity that they had in the 90s. And so essentially, those are essentially the same browser now. They have the same core and the same internals. It's just some stuff on top is a little bit different. Firefox is still a very unique browser, and I hope that never goes away. And then Safari actually shares a lot of parts with Chrome. They share the same rendering engine. So really, there's kind of 2 families of browsers these days. There's like Firefox and what's called WebKit-based browsers. So that's kind of the history of browsers. Let's talk about some of the details. Let me just make sure that I'm sticking to this. Okay. Yeah, I think I do need to. So when I go to a website in a web browser, so remember all this stuff is layered, that the web is built on top of the internet. To access the web, I need this thing called a web browser. There's really 4 main web browsers that are out there. There's another that's a little less popular called Opera. I'm not really sure the state or status of Opera. I've used it at previous times, but really if you were to look at the stats, the bulk of it is going to be those 4 browsers. Now to go to a website, you need 2 main things. Remember I told you before we had this system called DNS? that if I want to connect to the IRC website, I need their DNS name. I need their domain name, www.irsc.edu. Well, because the web is built on top of that, I actually need some extra things as well. So I need to know the domain name. I need to know the domain name. I need to know the individual page that I'm trying to access. And just like on your regular Windows computer, these pages are typically organized into files and folders. So it might be inside of the, if I was on the IRC page, it might be a folder called admissions, and then within that admissions folder, there might be a page for spring 2021 admissions or something like that. So we've got that part. We've got the actual domain name. We've got the what they have in orange, the path. And then we have this thing called the protocol. Now the protocol in this case is HTTP, which stands for Hypertext Transfer Protocol. Remember I showed you all that code before? That code is HTML, Hypertext Markup Language. And all the HTTP protocol does is it sends me all that code, essentially, and then the browser knows how to look at it and make sense of it. Now, when they first created the web, they had this idea that there were going to be way more protocols. Has anybody ever worked with FTP, File Transfer Protocol? So that's a protocol. There used to be some other protocols, but for the most part, what ended up happening is this HTTP protocol ended up becoming by far the most common. So if I were to go to a website today, it actually typically wouldn't be HTTP. It would be another protocol called HTTPS. Does anybody know the difference between HTTP and HTTPS? Yes?
One is more secured for financial transactions.
Exactly, yes. So the S in HTTPS stands for secure. Now, I've never really liked that name because it's sort of misleading. It sort of makes it seem like if something is secure, it can't really be broken. What it actually means is that it's encrypted. So if I were to send data over the internet, by default, it's not encrypted. Remember that slide before that I kind of complained a little bit about and I said that's not really true? The internet was never really meant to be secure. It was meant to be open. And so by default, there was really no authentication and no source of truth or anything, any sorts of those sorts of things if you want a secure thing. And so what we had to do is over time kind of bolt on and build on top of this set of protocols that has been around for a long time, security. And so what HTTPS does is that it makes it so that the content is encrypted. So the example you mentioned, if I was to go to a website, for example, my bank, and I logged into the bank, over HTTP, the unencrypted version, all those communications are plain text. If there were somebody in the middle of that communication that were able to what's called sniff that traffic, watch that traffic go across the wire, they could take my username and password and then log into the bank and then do whatever they wanted at that point. So what HTTPS does is that it has a little setup at the beginning, and it says, okay, this is going to be an encrypted session. Here's my certificates, all that information, and then from there, everything back and forth is encrypted. Now this thing as a whole is called a URL, Uniform Resource Locator. And this has, if I wanted to go to a website, this has everything I need to go to that website. It has the protocol, it has the full domain name, in this case www.nytimes.com, and then the individual page on the server that I'm trying to access. Let's take a quick step back and let's talk about this thing right here, this domain name. This is actually broken up into multiple parts. So see the thing in green, the .com? This is what's called a top-level domain name. And the idea is that through a place called a registrar, there's a bunch of these that are out there, I can go to, let's say a common one is, there's a company called Namecheap, and I can actually buy a DNS name. Or you don't really buy it, you kind of lease it. And from there, I say, okay, I want a .com, and I want NewYorkTimes.com. And then they tell me if it's available, and then from there I can get it. And this dotted notation is that it's supposed to get more and more specific. So .com is the top level, And underneath that, there's a company, New York Times, and underneath that, they have a server that they've called www, which is just a convention. If they had a mail server, they might call it mail.newyorktimes.com. If they had a chat server, they might call it chat.newyorktimes.com. An older technique that people used to use is that they would just randomly name things, like maybe after like cities in the or countries or places they visited or things like that. You don't tend to see that as often. Now it's common for people just to name it its function. If it's a website or a web server, they'll name it www. Okay, but that last part, that's what's called the top level domain. It used to be that these were somewhat limited. So you'd have .com, which would be for commercial, .org, which was supposed to be for like nonprofit organizations, .gov, which was for government offices. Then they started to add a few more. They had like, what happened was everyone wanted a .com. Even if you weren't commercial, it just became that like .com looked professional, so that's what people wanted. Then what they tried to do was create some extensions like .biz, and those really never caught on in popularity. It did a little bit, but then they just opened it wide open, where it used to be there was just a very small number of these top-level domain names. Now there's probably thousands or tens of thousands. Like I was driving the other day and I saw a local church was advertising, and it was whatever the church name was, .church. So I think people are getting used to some of these other domain names, other top-level domains. But yeah.
The top level domain that I kind of struggle with is IO, because IO has a reputation of being like an actor-based website, and there are some more secure websites that still use that domain, so that's what's kind of confusing.
Oh yeah. That's actually one that's gotten very popular lately is .io, and then there's .ai. I've seen a lot of people use, but okay. I think we're kind of getting, even though we've got a little bit of time left, I think that's a good stopping point. To me, they don't really have anything terribly interesting. I guess we could very briefly talk about what a search engine is. That should get you through the rest of the assignment. So if I've got all these servers out on the web with all this HTML, especially when the web was new and there were companies popping up left and right, how do I know which websites are the best? How do I know which websites have good information or even relevant information? So in the early days of the web, what people would do is they would get together and they would curate different information. And it was like people would actually go out and say, oh, this link looks interesting. Let me put it out here. This link looks interesting. And so that's how like Yahoo got its start, was they would actually, you'd go to, I can't remember what their names, they called them, there's a specific name. They're pretty much gone by now. But they'd actually have manually curated links. Now that's great and all, but the web is constantly changing. There's constantly new websites going out there. There's companies going out of business, and those links became stale very quickly. And it was just like this effort that you just couldn't keep up with it. And then people would try to get their website listed higher because they thought their website was, and there was politics. And so what eventually became popular to do is to do this algorithmically. And that's just society as a whole, is that a lot of these things that people used to do, we come up with very clever algorithms to do in a much more efficient manner. And so what they would do is they would actually electronically crawl every single website. So they would go to these things called registrars. They would get initial websites. They would look at links on websites, and they would go to other websites. And so they would actually crawl around the web, because remember, the web is all interconnected, and go to this website and say, oh, okay, I'm seeing a bunch of keywords about cars. So if somebody searches for cars, I might want to point them to this website. Now, I don't want to get into the details of it because these algorithms are incredibly complex. There's all kinds of weighting schemes that you have to worry about. You have to worry about people trying to defraud the system. You have to worry about like bait and switches, where it'll display one website for the crawler using browser detection, but then it'll display another website. It's a huge field of research. It's very complicated. But the basic idea is that you have some computer going out there and crawling around the web looking for keywords and terms, and then that way you can electronically go to a site like Google and just type in a keyword and it gives you back the most relevant websites. Okay. So I think that's good for today. You can use the last few minutes of class to just get a start on your assignment. Don't forget that this new assignment number 3, is going to be due in 1 week. Don't forget that you can always just click these assignments and get the information. Okay, so if there's no specific questions, I'm going to stop streaming here.